Hello, MLP training algorithm using back propagation of error. This we will be doing now. MLP, that is multi-layer perceptrons. So first some basics. We are considering here one hidden layer. So this is the input layer. So these X1, X2 are the inputs, and these input nodes, as we know, are just linear activation nodes, which means this A11 is nothing but X1, and similarly A21 is X2. So this is simply this input is passed on. Then we have this hidden layer weights, then one hidden layer, then the output layer weights which are connected to the output. We have gone through these computations in our earlier videos. Z12 is computed as the weighted sum of W11 into A11 plus a W21 into A21. Okay. Then we have the Z13, which is the output Z. And finally, the A13 is the GZ, where G is our sigmoid function. Now, a quick recap into gradient descent. So, this is the error function, and we want to reach this minima. So, differentiating the error function, we get the gradient of error. This is our error function, sum squared error, which will be summed over all output nodes. So the weights are trained so that the error goes downhill and reaches a local minima. And that is why we call this gradient descent algorithm. Also, just want to recall that we are using the sigmoid function, which has this form, and the gradient of the sigmoid function comes out to be gz into 1 minus gz. See, this is a kind of threshold function, but since it is continuous, it is differentiable. Now we will compute the gradient of errors to update the weights in the network. So first, for the weights which are connected to the output layer, and then to the weights which are to the hidden layer. And we can go back in this manner. If there were more hidden layers, we would have gone backwards. So this is, see, the computations are from right towards left. However, for the output neurons, the inputs are now different from the X. And for the hidden neurons, we do not know the actual output. And for if we had further hidden layers, if the input and output both would be unknown. So here comes the use of the chain rule of differentiation. Okay, so we would use this to go over this problem of how to find the outputs or the inputs for the hidden layer weights. So the MLP training algorithm, without using any formulae or any functions, we are simply stating it in words. Later on, we would put them all in, the functions would be included in the next video. So we have the input vector, it is fed to the network, and then we go on computing the forward computations, okay, till we generate the final output, then the error, and then it is fed backwards to first update out the second layer weights and then the first layer weight. Okay, so now we will see the gradient computation for the output layer. We have seen the forward computations here. These are the forward computations which are given here. Now the error is sum squared error for one output node. So we first compute the partial derivative of error with A13, which is this the A13 here. Then the derivative of A13 with Z13 and that of Z13 with W112 because we are finding the gradients for the weights of the output layer. So we have this first value here, and then we have the del A13 by del Z13, and finally this value. So the entire chain, now we write it down. Del E by del W112 is three components, this one, then this one, and combined together we get this, the entire thing. And this component we call it as delta 13 or delta JL. Okay, so error of node J in layer L. Now the gradient update is for W112 is the error multiplied by the input which is connected to this weight. See here, this is the weight W112 and the input coming to this weight is A12. So the gradient update is related with the error and the input connected to this. So this by defining this delta 13 or delta JL, we are able to define the gradient updates in a very good manner, very nice manner. This we'll see when we come to the updates of hidden layer weights, which we'll be doing in the next video. Or hidden layers in the done next. So until then, I hope you have understood this the basics of the MLP training algorithm and how the gradient computation for output layer is done. So thank you. Thanks for watching.